caption right here, which is all in the Ocean Commotion box, which is up front. There's multiple of these. Since this demo is a little bit bigger for the class that you'll be teaching, go ahead and just set one in the front, and we'll do this early on in the lesson. And then we have a separate salinity test that they're going to do afterwards. All you need for this is you need ice in one box and hot water in this box right here, and then a colored tap water that's room temp. So this blue is going to be put in this cold cylinder, while the red will be put in the heated up cylinder. So that's all you need for that. It takes a while to heat up the water, as we found out this morning. So definitely make sure you do that beforehand and make sure it's super toasty. Additionally, what's not on this sheet, which you might want to take note on, is the salinity test. What you're going to need for that is 3 different beakers, 3 different pipettes, 4 test tubes, and then 1 bigger bin to keep all those items in.
Guys, there's 2 things on your table. One's for Ocean Commotion, one's for oil spill.
Yes, so I'm sorry I didn't clarify that. Don't look at the one with the animals inside it, that's oil spill. So does anyone need me to relist that out for them? Are you guys good? Yeah, so you'll need 3 beakers, 3 pipettes, and 4 test tubes, and 1 bin. And then the water that we have in those beakers has different salinity in them. So one will be fresh, one will be a medium salinity, while one will be high salinity. And we'll go over that a little bit more when we get into it. So does the setup make sense to everybody? All right, cool beans. So we're going to get started. So Ocean Commotion. For this, we're going to talk a little bit about weather and climate first. Do you guys know the difference between weather and climate? Climate is permanent. So climate's permanent. What else is different between what's weather? Yeah, temporary. That's more of your day-to-day. Climate is going to be over a span of multiple years, and that eventually averages out to a particular climate, whether it's tropical, subtropical, temperate, or polar. What's the weather out today?
Foggy.
Yeah, it's foggy, cloudy. What was the weather yesterday?
Sunny, nice.
Sunny, yeah, it was super nice. So that changes very quickly, as climate will be pretty average over the span of time. Do you guys know what climate we live in? It's a good guess. We're actually in subtropical. So Florida, when you look at it, the very tip of Florida is in the tropical region, and the northern panhandle part is actually subtropical. When you get more into Alabama and the northern part of America, that's when you hit temperate, and any higher than that would be polar. Do you guys know what causes the climate? What's one of the main things that causes climate to be what it is? Where the equator is? Yeah, where the equator is and how the sun hits it. So, for a little demonstration, I need someone to be my Mr. Earth and someone to be my Mrs. Sun. Does anyone want to volunteer? Alright, I'll go light. Alright, you can be Earth. Alright, so the sun shines directly. Oh, you can also turn off lights for this if you want to make it better. So here we go. Alright, so if you hold this up to where the sun's hitting the equator in the middle, where do you guys see the most light at? Yeah, in the middle, so that causes it to be hotter. And is there a lot of sun at the northern poles and the southern poles? No, so that heats up the climate in those areas. Do you guys know what causes seasons? Whenever the Earth rotates. It's the rotation and the tilt of the Earth. So, can you tilt it down for me a little bit? There you go. What season do you think North America is in right now?
Summer.
Summer. And as it slowly goes down, to slowly tilt the Earth back for me that way, what season would we be in right now? Winter. We're actually pretty center right now, so we'd be in fall. We'll be in fall, and then eventually, if she tilts more, it would be in winter. And the opposite hemisphere would be in the opposite season. So not only does the impact of the sun affect climate, the tilt affects the seasons and everything. So, does that make sense to everybody? All right, everyone give a round of applause. to change because anytime there's water around, the weather is different. So when you're looking at the earth and you look at the oceans, are the oceans all connected or are they separated by land?
They're connected.
Yeah, they're connected. If I took my little finger and I went all the way around to each ocean, they are all connected. And the earth does a really cool thing that even though the sun is beating down on that equator, is it at a super extreme environment to where it's super, super hot, no one can survive, everything dies, too hot, hot, hot? No, and why is that, do you guys know? Yeah. The atmosphere, and what also affects the atmosphere? Something in the ocean that causes commotion. What's in the ocean that moves around and loops? Waves, circles, and currents. And I feel like I heard someone whisper, and if you didn't, I'm going to lie and say that someone did. Currents. Good job, everybody. So a cool thing that the earth does to balance out its habitat in different climates is it uses cold water from the north will filter down to that hot water and vice versa, and it makes it a livable habitat as well. So we are going to show you a little bit about how cold water and hot water mix. Does anyone know why? Does anyone think that hot water rises or cold water rises? Hot. Good. And why does hot water rise? Heat rises, but why does? Yeah, it's farther apart and actually causes it to be less dense. So the particles are going crazy and all over the place. It's very expanded. It's very light. When it's cold and it's like together really tight, it makes it a lot more dense and allows it to sink. So that experiment we're going to show you with this. And there is hot water coming from via cave, eventually. And what we're going to see with this is you're going to see the cold water in this. As the water gets cold, it's going to sink down to the bottom as the hot water will be on the top. And then I'll probably have 2 people pour this at the same time, and then you want to fill the water up to probably just over this top tube, so about right here.
Good job. Nice teamwork.
Is it stuck?
Air bubble.
Oh no. That wasn't supposed to happen. You can use my pencil. Thank you.
I don't know if
Yeah, it has that covered.
Yeah.
I thought it would air out the air.
Oh.
That didn't help.
It's kind of working. Now you're pushing the other way though. It's kind of working.
Just go.
Okay.
That's a good idea.
Don't do that.
Don't do that. That was supposed to happen when we did this.
Dang, it's really
Pick up that end of the table a little bit.
it's really
It worked so well.
Could you suck on it?
The air out. You poured more into it.
Leave it on?
Yeah, just pour
This
it.
is just this side. Don't make compression.
It's coming out. There we go.
Some of the air.
A little bit more.
Ah,
There we go. It's not really.
If you just pick up one side of the table, the bubbles will come out the other side.
oh well, sometimes it works, sometimes it
If you pick
doesn't.
up the hot side, the air is on the other side.
What happens if it
Oh,
happens?
so smart.
There you go.
Oh!
Yay.
So,
Ain't nothing way to
as
stick
it's
in.
heating and cooling, you're going to notice this bottom tube gets all of the blue cold water running through it as this top tube becomes warm. And you'll see it start creating a circle current through it. So this is essentially what happens with the north end of the water versus near the equator. And it causes something called a gyre. Do you guys know what a gyre is? You don't have to tell the kids this, but this is just good to know.
They haven't learned that yet.
Oh, you haven't? Okay,
No.
so a gyre is just essentially the loop that's created by currents of hot and cold water circulating. So if you have extra time and they seem really smart, you can throw that tidbit in there as well. So we're gonna just let this go because it does take some time, but just periodically look at it, and you can even see now that warm water streaming into it. So the next thing that you want to go over is the density. So when water is colder, the salt has a higher concentration in that area and makes it more dense than it does in different areas of warm water. So the experiment for salinity that you have at your table, which is incorrect right now, but just to note for yourself later, is that it should be that the blue dyed water in your beaker should have a higher concentration of salt in it. That would represent polar climates. The yellow will have a medium amount of salt, which represent temperate climates, as the red would have just fresh water that represents subtropical and tropical climates. Does that make sense to everybody? All right. So what you'll do at this point is you'll break off into your teams, and you'll have probably about 4 people or 3 people teaching with you. And what you'll do is you're going to have the kids kind of guess the mixture of how dense each water is, because they're not going to know if polar is more dense, if subtropical is more dense, or temperate. So what you're going to have them do is you're going to talk about, this is a test tube. Does everyone know what a test tube is? When you put your liquid in it, there's no cap, so don't turn it upside down. That's no fun. This is a pipette. How you use a pipette is you squeeze this, it squeezes all the air out, and then you use it to suck all the liquid back in. And whenever you're layering, what you're gonna do, if you hold your test tube like this and just go straight in, you're basically gonna mix everything, and you're not gonna see the cool layers of density. So what you're gonna do is you're gonna hold it sideways like this, and have the pipette slowly and layer those colors on top. And what you should find the mixture is you should see which one is more dense. If you put the most dense on top, what's going to happen? Yeah, it's going to sink and mix, and all your colors are going to blend together. But if you have the kids get it perfectly, it's going to give you cool layers. So that's what we're going to do. We're going to just break out. I guess you take those 2 tables. I think these 2 tables.
Hayden can do
Hey,
that
you know
table.
this?
Hayden can do that table.
Yeah, Hayden, you could do that,
Yeah,
Taylor.
we do this table. Alright, I'm just gonna talk to both of you.
So I want you guys to do is that
We will
you
know.
will have
Pretty much what you guys do.
pretend like you're a kid,
Pretty much, you're gonna
and you're
grab
putting the
my
colors
bed
together and
and
try to see
and
which
the
layers.
kids will not know which is the most dense and which is the medium and which is the least dense. So you're gonna have them figure that out by trial. So when you're talking to the kids, like, all right, you do the blue first, you do the yellow first, you do the red first, and then once they've done that, you're like, all right, now you do this color, you do this color, you do this color, and then based on which one has the one where they're all separated by color, you have them guess what color is the most dense, what color is the least dense, what color is right in the middle, right in between. So y'all can go ahead and try this. That's all y'all. Easy peasy. I'm helping you on your lap partner. Alright, so I got some juice. I think we're gonna go blue. Alright.
It's the best.
No, I disagree.
There you go, perfect.
Thanks, cheating.
Now it's gotta be yellow.
And it should
I don't
be
say, whatever
where
sort of
it's
before.
opposite right
Guys,
now. So the
red is more dense than blue.
has more
Yeah, and you
Spoiled.
No.
don't spoil it.
We're supposed to work together.
Time to work.
It's the opposite.
We got green.
It's the opposite. Red's the heaviest.
Just dump your fun.
I think
Give me the
blue
yellow.
is still on the
Give
bottom
me the,
though.
give me the, give me the yellow.
You're cheating.
It's like colored water. Yeah. Except
Hayden,
salt.
Hayden, red's the heaviest. It's mixed up.
But we have to dump this part out.
Yeah.
So what do we do with this? We just dump it in the oil spill? Okay.
Just get up.
I don't want to get up.
Mine's a mixer.
Guys, it's either yellow, red, blue, or red,
so
blue,
then that
yellow.
one.
Or I mean
No,
red,
you do
yellow,
not drink
blue.
it. So pour it out.
It's either yellow, red, blue, or red, yellow, blue.
And
then it's more.
Wait, just there?
There you pulled that to the right.
Alright, so red goes first.
It's alright.
I win.
Yeah, that's it.
All I did was mixing. You're putting them in too fast.
That was so slow.
If it would turn into a rainbow if you did it if the colors were right, and then if you put it like gently in there.
So it's a little bit backwards from what I said because we just did the wrong colors, but this will have the most salinities and this less, and then this is the fresh.
But when y'all actually do this activity, you want the blue to be the most clear. Next, we'll put it in really slow. Really slow.
I realize I'm not doing this right.
Yeah, I might be able to watch that next.
Red went up.
Okay.
So Ben lied to us.
No, he didn't put it gently.
As usual.
What do you
I
mean?
did
Red
put
is
it-
heavier than yellow and blue is the lightest.
If blue is the lightest, that means blue goes up top.
Yeah, blue's fresh water. I mean, no water.
No water.
You mean no salt?
Yeah, no salt.
No water.
No water.
thought
What is
blue-
it, Gavin? What is it? Alright, so we'll go red, yellow, blue.
Yeah,
See if
red,
it's-
yellow, blue works.
It's supposed to be. They did say it was wrong though.
Alright, now slowly do the yellow. Really. I swear to you. It's just mixing.
There is no salt in
Maybe because you're bad at it. I did it. Wow.
Ben, let me see yours,
Now we're
man.
throwing shade.
We show some white.
I'm gonna throw my test tube at
These tests are tearing us apart.
me mad, and he said I was.
It should actually look like a rainbow, but close
Mine's
enough.
not mixing this time.
I did.
What?
Blue, yellow, red.
Did you guys do it? Yay! Wow!
Bye.
Cool.
No.
I got mine.
It's actually iodine.
You
You know what? He'll live. Not good.
Oh, you did it.
Iodine in it.
Wait, why did I
But
put red
I
in
can't believe you lied to me. Mine's yellow, blue.
I made it wrong in the first place. I didn't even put red in here.
Hayden, aren't you like a second year? You're supposed to be knowing how to do this.
I'm letting him live.